Hey everybody, welcome. I see some familiar names here. Hey Hutch. Hey Stefan. Nice to see you guys again.
Good morning and good afternoon. I hope you all are feeling great today. Welcome to the webinar for building a disaster recovery plan with AWS. My name is Joseph Abada, and I am one of the speakers for the event today. Thank you everybody for joining in. We do have some great content to present for the event today, and I have some couple of solutions architects who would be joining me, Mark and Shikhar, and we'll spend some time introducing ourselves in a while as well. So let's kick this event off. We start with a very high-level agenda for our webinar today, just to make sure we align our expectations and our deliverables well. We'll do a quick introduction about the speakers, who we are, a quick overview of Mission Cloud Services, who we are, what do we do on AWS, and all of it. Then we start with a discussion on DR on a very high level, right? A few bullet points, what a disaster actually means on cloud, and what makes a disaster recovery on cloud. Then some differences around disaster recovery and availability. Understand the AWS shared responsibility model, why it matters from a customer perspective from AWS, and then understand the bit of logistics, how DR works in a cloud world versus a traditional on-premises manner, and understand the major differences between these two approaches, and then understand more on the availability versus DR. A lot of times there are those confusions for customers of HA versus DR, and genuinely trying to understand how to build a DR strategy for, right? And then understand more on the region versus one region versus multiple regions on AWS, and how does the AWS global region look like today. Then we look at the one of the core important topics is around DR strategy. How do we build one? What is a business continuity plan? What are the terminologies around RTO and RPO? How do you build one? And understand all of that. And then evaluating several of those DR strategies to be built on AWS as well. And we ended with a partner case study from Mission, where we as Mission has helped one of our customers to build a DR on AWS. Lastly is a summary and Q&A. So we would like to make this webinar very interactive as much as possible. So we'll have our chat and our Q&As opened up throughout the event. So feel free to ask us questions during the presentation. And we'll also take some time off at the very end to answer all of those questions with best of that. So I think let's begin. Here are the three technical speakers. I'll go first for the event and then do a quick introduction for ourselves. So my name is Joseph Abada. I'm a solutions architect with Mission from Chicago, Illinois. A little bit about me is I came from a development background, primarily on sysadmin, cloud operations, and then moved to pre-sales. I've been working on cloud for several years now, worked with several segments, including healthcare, life sciences, banking, fintech, with verticals from startups, SMBs, and even enterprises. My primary responsibility with Mission is to help our customers on their cloud journey, right? Whether they're trying to look to migrate workloads to cloud or build something on cloud, that's something that I help my customers with. I help with designing and solutioning and all of it as well. That's a quick high level about me, and I'll let Mark introduce himself next. So over to you, Mark.
Thanks, Josefa. Hey everybody, my name is Mark Richmond. I'm a senior solutions architect here in AWS's small and medium business organization. I'm based out of Orlando, Florida, and I serve as a CTO level strategic advisor to our customers here in Florida and beyond, helping them architect and modernize their cloud solutions. So ultimately, my role is to help customers achieve their business outcomes with the most efficient architecture at the optimal cost. I've been in engineering for over 25 years. I've been here at AWS for about a year and a half, though I've been an AWS customer for almost 10 years now, and really looking forward to today's session. Shikhar?
Thank you, Mark. Hello, everyone. Good morning, good afternoon, depending upon where you are. My name is Shikhar Mishra, and I'm a senior solution architect here at AWS. I do support small and medium business as well. I've been with AWS for more than 1.5 years now, and I've been in the industry for more than 14 years. I'm based out of DC area, and what I do in my day-to-day job is to provide architectural guidance, best practices, recommendation, and any service deep dives for my customer. I work as a customer and technical advisor for them. So looking forward for this session, and feel free to ask any questions if you have.
Sounds good, guys. Let's continue with this slide deck. Okay, a little bit about Mission, right? Who we are and what do we do? So Mission is a premier AWS consulting partner. What that means is if you are aware of the AWS partner ecosystem, AWS grades its partner on the level of expertise, competencies, and certifications, case studies, and all of it. Based on that, a partner achieves that competency level. So Mission is one of those premier partners with AWS. It was founded back in 2017 by a merger of 3 companies across US with a combined cloud experiences of over 10 plus years now. It's a quick and fast growing team of 260 plus members and counting. We have hundreds plus technical resources, certifications, and all our team members are completely remote across the country. Here at Mission, we appreciate our data very much. We would like to present our NPS and CTAT scores to our customers and partners and be pretty much transparent about that as well. We have several competencies while delivering workloads on AWS, like migrations, DevOps, Microsoft workload, security, data analytics, and machine learning. And that makes our preferred AWS partner for us. And we work with a lot of designations behind our back, catering managed services, well-architected partner, Microsoft, or even Redshift partner. So that's a quick background about Mission and our offerings. I will hand it over to Mark to continue with the presentation. Over to you, Mark.
Thanks, Azefa. So the theme of today's presentation is really managing failure. And Werner Vogels, who's the CTO of Amazon, has famously said, everything fails all the time. And that really couldn't be more true. Failures are a given, and everything will eventually fail over time, from routers to hard disks, operating systems to memory units, corrupting TCP packets, from transient errors to permanent failures. This is a given, whether you're using the highest quality hardware or the lowest cost components. And what Werner says is true for really any complex system, such as our distributed systems and the environments in which they run. But we don't need to accept failure in our systems. Instead, we build systems that work despite those failures. And when I say we, I talk about the shared responsibility that we at AWS share with you, the customer. So AWS, these components abstract away low-level failures like hard drives and power supplies, and our services are built using best practices like redundancy. The customer's responsibility is to use the tools that AWS offers so that their workloads follow best practices. So things like disks, CPUs, power supplies, AWS abstracts all these away. But sometimes bigger issues can sometimes bubble up, and the services that we at AWS offer help mitigate those failures. Failure prevention in and of itself is a good thing, but failure management handles the failures that occur despite this prevention. All right, so what is disaster and disaster recovery? And there's 3 categories here that we want to touch on. So when we're planning for disaster recovery, we want to evaluate our plan for these 3 main categories. So first is natural disasters. These are the obvious things like earthquakes or floods, or I guess it's a volcano there in the picture. Technical failures, such as a power failure or network connectivity issues, or any kind of human action. Inadvertent misconfiguration or some unauthorized or outside party that has access to or makes some kind of modification to the system. Could even be a bad actor. So each of these potential disasters will also have geographical impact. That could be local, regional, countrywide, continental, or global. Both the nature of the disaster and the geographical impact are important when you're considering your disaster recovery strategy. So for example, you can mitigate local flooding issues causing a data center outage by employing what we call a multiple availability zone or multi-AZ strategy, since it would not affect more than one availability zone. But for example, an attack on production data, that would require you to invoke a disaster recovery strategy that fails over to backup data in, say, another AWS region. So what's the difference here between disaster recovery and availability? So both availability and disaster recovery rely on some of the same best practices like monitoring for failures, deploying to multiple locations, and automatic failover. But availability focuses on components of the workload. Disaster recovery focuses on discrete copies of the entire workload. So disaster recovery has different objectives from availability, measuring time to recovery after the larger scale events that qualify as disasters. So the first thing you want to do is ensure that your workload meets your availability objective. A high availability architecture enables you to meet your customers' needs in the event of availability impacting events. So your disaster recovery strategy requires different approaches than those for availability, focusing on deploying discrete systems to multiple locations so that you could fail over the entire workload if necessary. All right, so before we dive deeper into various DR strategies, I want to take a minute just to walk through AWS's global infrastructure. So these are the AWS regions and availability zone, or AZ, concepts. So AWS has 26 regions located all over the world, and we're planning on launching many more. We just opened another AWS region in Japan earlier this year, and within each region are multiple availability zones. So these balance between synchronous replication and disaster mitigation. So these are areas separated by a meaningful distance for disaster mitigation, but close enough to each other for synchronous replication. So typically between, an area like within 60 miles or 100 kilometers of each other. And each availability zone represents one or more discrete data centers. Just want to contrast this real quick to other cloud providers. So each AWS region has multiple AZs. Each AZ has multiple physically separated data centers. Just for a comparison, some competing cloud providers might claim to have over 50 regions, but most of these regions have no availability zones. They're just one data center. So it's really an apples and oranges comparison to the multi-AZ, multi-data center AWS region. Also, each AWS region, has two independent, fully redundant transit centers that allow traffic to cross the AWS network, enabling regions to connect to the global network. And also, we don't use other backbone providers for AWS traffic. Once it hits the AWS backbone, it stays private to the AWS network. All right, so I touched on this just a minute before, the AWS shared responsibility model. So resiliency is a shared responsibility between AWS and you, the customer. So it's important that you understand how disaster recovery and availability as part of resiliency operate under this shared model. So AWS's responsibility is what we call resiliency of the cloud. So AWS is responsible for resiliency of the infrastructure that runs all the services offered in the AWS cloud. So this infrastructure comprises the hardware, software, networking, and facilities that run the AWS cloud services. So basically everything on the bottom of the screen there in orange. AWS uses commercially reasonable efforts to make these cloud services available, ensuring service availability meets or exceeds the SLAs that we advertise. The AWS global infrastructure is designed to enable customers to build highly resilient workload architectures. Like I said before, each region, it's fully isolated, consists of multiple availability zones, physically isolated partitions of infrastructure. So AZs isolate faults that could impact workload resilience and preventing them from impacting other zones in the same region. At the same time, all the zones in the region are interconnected. They're fully redundant, dedicated fiber, They provide high throughput, low latency networking between those zones. And all the traffic between those zones is fully encrypted. Very important to note. The network performance is sufficient to accomplish synchronous replication between those zones. So when you construct your application and deploy that on AWS, it can be partitioned across AZs. And when you do that, you're better isolated and protected from issues like power outages, lightning strikes, tornadoes, hurricanes, and a lot more. Now, to contrast that, the customer's responsibility here is resiliency in the cloud. So AWS is responsible for the resiliency of the cloud. The customer is responsible for resiliency in the cloud. So your responsibility here, and everything at the top of the screen in blue is yours, the customer's. It's really determined by the cloud services that you select. So this will determine the amount of configuration work you have to perform as part of your resiliency responsibilities. So for example, a service like Amazon Elastic Compute Cloud, or EC2, this requires you, the customer, to perform all the necessary resiliency configuration and management tasks. And if you deploy EC2 instances, you're responsible for deploying those across multiple locations like AZs. You have to implement self-healing architectures like AWS autoscaling and using resilient workload architecture best practices for applications installed on those instances. If you move higher up in the set of managed services like Amazon S3, Amazon DynamoDB, AWS operates the infrastructure layer, the operating system, and all the platforms, and the customers access the endpoints to store and retrieve data. In those cases, you're only responsible for managing the resiliency of your data, so backup, versioning, and replication strategies. AWS takes care of the rest. Deploying your workload across multiple AZs in a region is part of a high availability strategy designed to protect workloads by isolating issues to one AZ and uses the redundancy of the other AZs to continue serving requests. So a multi-AZ architecture is also part of a DR strategy designed to make workloads better isolated and protected from issues such as power outages, lightning strikes, and others that I mentioned. DR strategies can also make use of multiple AWS regions, and we'll go into that a little bit more later. For example, in an active-passive configuration, service for the workload will fail over from its active region to its DR region if the active region can no longer serve requests. All right, so disaster recovery is very different in the cloud than on-prem. So disaster recovery strategies evolve with technical innovation. So a DR plan on-prem might involve physically transporting tapes or replicating data to another site. Your organization needs to reevaluate the business impact, risk, and cost of its previous data center recovery strategies in order to fulfill its DR objectives on AWS. Disaster recovery in the AWS cloud includes the following advantages over traditional environments. So you can recover quickly from a disaster with reduced complexity. You have simple and repeatable testing that allows you to test more easily and more frequently. You have lower management overhead, which decreases your operational burden. And you'll have opportunities to automate, decrease chances of error, and improve recovery time. So AWS allows you to trade the fixed capital expense, or CapEx, of physical backup data center for the variable operating expense of a right-sized environment in the cloud, which can significantly reduce your costs. If your workloads are on AWS, you don't need to worry about data center connectivity, with the exception of your ability to access it. Power, air conditioning, fire suppression, hardware, all this stuff is managed for you, and you have access to multiple fault-isolated availability zones. All right, so just to alleviate some confusion here, high availability is not disaster recovery. So what do we mean by that? So you have to consider the availability of your workload in your disaster recovery planning, as it will influence the approach that you take. A workload that runs on a single EC2 instance, for example, in one availability zone, does not have high availability. So if a local flooding issue affects that AZ, this scenario requires failover to another AZ to meet your DR objectives. So compare this scenario to a highly available workload deployed multi-site active-active, where the workload is deployed across multiple active regions and all regions are serving production traffic. So in this case, even in the unlikely event a massive disaster makes a region unusable, the DR strategy is accomplished by routing all traffic to the remaining regions. So how you approach data is also different between availability and disaster recovery. So consider a storage solution that continuously replicates to another site to achieve high availability, such as a multi-site active-active workload. So if a file or multiple files are deleted or corrupted on the primary storage device, those destructive changes can be replicated to the secondary storage device. So in this scenario, despite high availability, the ability to fail over in case of data deletion or corruption will be compromised. So instead, a point-in-time backup is also required as part of a DR strategy. And we have multiple AWS services that do offer point-in-time backup. Okay, single region versus multiple region. I think, is this a duplicate slide, Josefa? I think we might have a dupe slide. Let's skip to the next one. I think we have a dupe. All right, thanks. All right, so business continuity plan, RTO versus RPO. So your DR plan should be a subset of your organization's total business continuity plan, or BCP. It shouldn't be a standalone document. So there's no point in maintaining aggressive disaster recovery targets for restoring a workload if that workload's business objectives can't be achieved because of the disaster's impact on elements of the business other than your workload. So, for example, an earthquake might prevent you from transporting products purchased on your e-commerce application. Even if effective DR keeps your workload functioning, your business continuity plan needs to accommodate transportation needs. Your DR strategy should be based on business requirements, priorities, and context. So you could document the threat, risk, impact, and cost of different disaster scenarios and the associated recovery options. So this information should be used to determine your recovery objectives for each of your workloads. So when you create your DR strategy, the most common plan here is for recovery time objective, RTO, and recovery point objective, RPO. And we'll talk about RTO and RPO a lot. I'll define both of these for you. So recovery time objective, RTO. This is the maximum acceptable delay between the interruption of service and the restoration of service. So this objective determines what's considered acceptable time window when the service is unavailable and is defined by the organization. Recovery point objective, RPO, this is the maximum acceptable amount of time since the last data recovery point. So this objective determines what's considered an acceptable loss of data between the last recovery point and the interruption of service, and this is also defined by the organization. So recovery time objective measures delay, recovery point objective measures data loss. All right, and we're going to elaborate in the next section that Chicker's going to take over for me to talk about various disaster recovery strategies and the architectures on AWS for each. Disaster recovery strategies available to you within AWS can be broadly categorized into 4 approaches, ranging from the low cost and low complexity of making backups to more complex strategies using multiple active regions. So active passive strategies use an active site like an AWS region to host the workload and serve traffic. The passive site, so a different AWS region, is used for recovery. So the passive site doesn't actively serve traffic until a failover event is triggered. It's critical to regularly assess and test your disaster recovery strategy so that you have confidence in invoking it should it become necessary. We have a service called AWS Resilience Hub that can continuously validate and track the resilience of your AWS workloads, including whether you're likely to meet your RTO and RPO targets. For a disaster event based on disruption of loss or one physical data center for a well-architected, highly available workload, you may only require a backup and restore approach to disaster recovery. If your definition of a disaster goes beyond the disruption of loss of a physical data center to that of a region, or if you're subject to regulatory requirements that require it, you should consider pilot light, warm standby, or multi-site active-active. And we're going to go into these in much more detail in a minute. When choosing a strategy, and the AWS resources to implement it, keep in mind that within AWS, we commonly divide services into what we call the data plane and the control plane. So the data plane is responsible for delivering real-time services, while the control planes are used to configure the environment. So for maximum resiliency, you should use only data plane operations as part of your failover operation. So this is because the data planes typically have higher availability design goals than the control planes. Okay, so before I hand this off to Sugar, I think we might have a couple of questions here. I think the first one here is, what are the best practices to determine RTO and RPO? All right, so great question. So your mileage may vary here. Your different businesses will have different RPOs and RTOs. But the methodology in general to calculate RPO and RTO, they're pretty similar. So you want to start with understanding the cost of downtime for your organization. That's the number one thing, right? How much money are you going to lose if you're down? Next, you want to build an inventory of every system and application used by your organization. You don't want to neglect internal teams, end users, anyone affected by systems that are rendered unacceptable. So going back to like RPO and RTO, for RPO, like how much data do we project to lose if your operation's interrupted? How much data loss can you tolerate? What's the cost of lost data? What's the cost to re-enter that lost data? What would it cost to implement a solution that can meet those requirements? For RTO, how much revenue do you project to lose if the system goes down? Does the system handle customer data? If so, what are the SLAs in place with your customers? If the system went offline, does it have dependencies? What other systems would be impacted? What are the RTOs for those systems? And so on. So great question. If you have any more follow-ups to that, drop a note in chat and I will respond. For now, I will thank you for your time and hand it over to Shikhar to pick up the rest.
Thank you, Mark, for talking about the DRE strategies on a high level in AWS. And I will try to go a little bit deeper into the scenarios where we can actually use these strategies. So let's talk about the first strategy we have, and it is called backup and restore. And I'll talk about first what this strategy is, right? So it's a suitable approach for mitigating against data loss or corruption. Now, backups are point-in-time copy of your data to prevent any logical error, such as any system failure, application error, or any accidental deletions that might happen as a mistake. Backups can be run on premises to the cloud, either directly to a cloud target or via a gateway appliance. If you are using your workload or if you have deployed your application in AWS, you can enable the backup, which most of the AWS service natively offer. Now, given that you can directly or through a gateway appliance backup on-prem data to AWS, that means that you can leverage your existing backup infrastructure. Now, this approach can also be used to mitigate against a regional disaster by replicating data to another AWS region or to mitigate lack of redundancy for a workload deployed to a single availability zone, right? And that's the point which Mark was explaining about what is the difference between high availability and a disaster recovery. Now, in addition to data, you must redeploy the infrastructure, configuration, and application code in the recovery region. Now, let's look at the architecture and services that support this approach in AWS. As you can see in this architecture, a backup of your database and application storage is backed up and stored in a DR region, right? In addition to data, like I said, you need to deploy your infrastructure configuration and code as well in the recovery region. And to enable that and to be redeployed this quickly without any errors, you can always use and deploy using infrastructure as a code. And we have a few services available to do that. A couple of those are AWS CloudFormation and Cloud Development Kit. CloudFormation gives you basically an easy way to model a collection of related AWS and third-party resources. So you can provision your resources very quickly and consistently and manage them throughout their life cycle by treating them as infrastructure as a code. The another service that I mentioned is Cloud Development Kit, which is an open source software development framework to define your cloud application resources using familiar programming languages, which you have been using like Python, Java, and so on. Without IAC, it may be complex to restore the workloads in the recovery region, which will lead to increased recovery times and possibly exceeding your RTO. In addition to the user data, be sure to also back up code and configuration, including your Amazon machine images that you can use to create your EC2 instances. You can use code pipeline to automate the deployment of your application code and configuration to a different region. If you're using DynamoDB database, which is a fully managed serverless key value NoSQL database that we offer, you can use AWS Backup or DynamoDB service to create automated or scheduled backup in the same or different region. The last part is about EBS, right? So if you are using EBS, which provides block level storage volumes to be used with the EC2, you can create regular incremental snapshots. And EBS itself offer that service to you, or you can use AWS Backup to copy those backup and snapshots across account, right? And when you do a cross account backup capability, you're also protecting your environment from the disaster events like insider threats or any account compromise that can happen. Let's move on to disaster recovery 2, right? So, and it is called a pilot light scenario. So in this strategy, we have resources that are built around a replicated data set, right? This basically leaves all these resources staged in a stop state to respond to a disaster scenario. So whenever there is an event which dictates an event disaster, we start this pool of resources, cut them over to AWS production, and use services like auto scaling to match the required production capacity that you are running in your primary region. With the pilot light approach, you replicate your data from one region to another and provision a copy of your core workload infrastructure in the secondary region. The resources required to support this data replication and backup, such as databases, object storage, these are always on, right? Other elements such as application server, code configuration, these are copied as a backup, but they are in a switched off state. Unlike the backup and restore approach, your core infrastructure is always available. That means that you always have the option to quickly provision a full scale production environment by switching on those application instances and scaling out your application servers. Let's look at the architecture for pilot light, right? So for pilot light scenario, you have a continuous data replication to live databases and data stores in the DR region. And that is the best approach for having a lower RPO. Now, if we look at this architecture quickly, you will see the critical components like database, which is Aurora here, is continuously replicated in the secondary region, whereas other application components are backed up into the different region. Now, the other services that you can utilize for achieving this strategy is if you are using Amazon Simple Storage service, which is our object storage service offering industry-leading scalability, availability, and security. You can use cross-region replication, right? That's a functionality that is natively offered by S3. And you can use cross-region replication to asynchronously copy all the objects from one S3 bucket in the primary region to another S3 bucket in the DR region continuously. If you're using completely managed relational database service in cloud, you can also use replicas to keep your database replicated in the DR region, right? So if you're using services like Aurora, you can create up to 15 replicas of your database. If you're using DynamoDB, then you can utilize something like Global Table, which deploys a multi-region, multi-active database. Okay, so moving on, let's talk about our third disaster recovery strategy, which is warm standby. A warm standby is suitable for solutions that require an RTO and RPO in minutes. And these are typically your core business critical functions, and they are slightly higher cost DR options compared to the other two that we talked about. And it is a scaled down version of your fully functional environment in this case. It is always running in the cloud for one standby. The warm standby DR approach requires replication of data and services in the AWS cloud so that a full failover to the cloud can instantly occur in the event of a disaster. The distinction between Pilot Light and warm standby is that Pilot Light cannot process requests without any additional action being taken first. Whereas if you're using warm standby, it can also handle traffic, but at a reduced capacity level. The Pilot Light approach requires you that you turn on the server, possibly deploy additional infrastructure, and scale up, whereas warm standby only requires you to scale up, right? Everything else is already deployed and running and at the reduced capacity. Okay, so let's look at the architecture for this strategy, right? So this approach extends the Pilot Light concept and decreases the time to recovery because your workload is always on in another region. This approach also allows you to more easily perform testing or implement continuous testing to increase confidence in your ability to recover from a disaster. All other services that you use for replicating data like global database, S3 cross-region replication that I talked about in the last slide, they're also used in this approach as well. For an active passive configuration such as Pilot Light, all traffic initially goes to the primary region and it is switched to the disaster recovery region when the primary region is no longer available. This failover operation that I'm talking about can be either initiated automatically or it can be switched manually. One service that you can use to do that is Amazon Route 53. Now, Route 53 is a highly available and scalable domain name service that we offer. Using Amazon Route 53, you can associate multiple IP endpoints in one or more AWS region with the domain name that you configure. You can also route traffic to appropriate endpoint under the domain name and fail over to the secondary region directly managed and handled by Route 53 itself. Another service that we use is auto scaling here a lot, which keeps monitoring your application and automatically adjusts capacity to maintain a steady, predictable performance at the lowest possible cost. Auto scaling is also used to scale resources, which can include like EC2 if you are using, or ECS, which is our Elastic Container Service. It can also use DynamoDB and Aurora. It can also manage DynamoDB and Aurora replicas as well. Okay, so moving on, talking about the disaster recovery strategy 4, you can run your workload simultaneously in multiple regions as part of multi-site active-active or hot standby strategy. So multi-site active-active serves traffic from all the region to which it is deployed, whereas hot standby serves traffic only from a single region, right? And all other region that they have in this strategy is basically used for disaster recovery. With a multi-site active-active approach, users are able to access your workload in any of the region where it is deployed. In hot standby, uses basically an active-passive configuration where users are only directed to a single region and DR region does not really take any traffic. Okay, so most customers find that if they are anyways going to stand up a full environment in the secondary region, it makes sense to use it in active-active mode, right? Which is multi-site active-active configuration. Alternatively, if you do not want to use both region, then you can use warm standby, which offers a more economical and operationally less complex approach. The asynchronous data replication is needed for this strategy, which basically enables the near zero RPO. You can use services like Amazon Aurora Global Database, which uses dedicated infrastructure that leaves your database entirely available to serve your application in the secondary region. If you're using DynamoDB, then global table is the option that I talked about. You can create those global tables, which is a native functionality and provides a fully managed multi-region and multi-active database for massively scaled and global applications. For routing the traffic, you can either use Route 53 or Global Accelerator, and the policies that you can set could be a percentage of traffic that you want to divert to different regions, Or if you're using Route 53, you can use other policies like geo proximity or latency based policies. So that way these services can redirect your traffic as well. Now let's talk about the disaster recovery strategy 4, which is the newest service that we have launched. So we recently launched Elastic Disaster Recovery Service, which replicates your servers without any performance impact using cost-effective AWS resources to keep your application up to date on AWS. In the event of any IT disruptions or disaster, you can recover your entire environment within minutes with your application running natively in AWS. DRS reduces cost by removing the idle recovery site resources, and you only pay for the resources that is provisioned and utilized during either a drill or during a recovery. For AWS-based application, you can use DRS to recover application in another AWS region, which can help you meet your resiliency and your availability goals for these applications. DRS automatically provisions and manages a staging area subnet within your AWS account, which leverages cost-effective AWS resources to receive your replicated data without incurring any significant cost. With flexible usage-based hourly billing per source server, you can easily add and remove servers from your disaster recovery environment and can save money because it's obviously a pay-as-you-go model. Some of the benefits that you get with DRS is you can meet the most stringent RPO and RTO requirement. You can lower your total cost of ownership for your disaster recovery, and you can pay for what you need as you go. You can also use the same simple process to operate regardless of the OS versions or application that you're using. You can also conduct frequent DR drills without impacting the replication or any user activities or your primary region. Okay, so before I hand it over to Josefa, I want to talk a little bit about well-architected pillar. So AWS has a framework which is called Well-Architected, which helps cloud architect build secure, high-performing, resilient, and scalable applications. It is built around 6 different pillars, which are operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Well-architected framework provides a consistent approach for customers and partners to evaluate your architecture and implement scalable designs. So whenever you are deploying your application in production and setting up a disaster recovery, don't forget to use the well-architected tool to review your workload before they go live in the production and on a regular ongoing basis. If you're an enterprise support customer, you can also ask your technical account manager or your solution architect for an operational review to identify any risk in your operations as well. With that, I will hand it over to Josefa.
Sure, Shikhar. Thank you so much for that. Before we jump on to the next one, I just want to be mindful about any questions that we have in the chat or in the post. Okay, I see one. I think that's for you, Shikhar. Is what operating systems and applications are supported by the AWS Elastic Disaster Recovery?
Okay, great question. I think I kind of mentioned it in the last slide, but when you use Elastic Disaster Recovery, you can recover your application on AWS for any physical hardware, be it VMware, vSphere, or if it is Microsoft Hyper-V, or it could be a cloud infrastructure for any other cloud providers. You can use Elastic Disaster Recovery to recover your EC2 from the different availability zone or in a different AWS region. Most of the major operating systems like Windows and Linux are supported here. Within Linux, we have Red Hat Enterprise Linux, Ubuntu, CentOS, Debian. All these major platforms are supported, but I will still suggest to go back and look whenever you're deploying, just to go back and check the compatibility metrics once before you deploy it in the production. I hope that answers the question.
Perfect. Thank you so much for that, Shikhar. Let's move ahead to the next one. Okay, so as a part of this webinar, we also like to present a partner case study from Mission, and that's for one of our Mission customers known as Centage. So a little bit about Centage is a fintech company, and what they do is they offer cloud-based financial planning solutions for like budgeting, forecasting, reporting, and analysis. Centage came to Mission as they were looking to migrate their core financial intelligence application to AWS. And the main reasons to do that were a few actually, were around modernizing their workloads, lowering their overall IT costs, and then also providing a better performances and experiences to their own customers. And then once Mission engaged, we had a rounds of discussions, scoping, understanding the business requirements, and then engaging with Centage for multiple projects. We started off with a migration. We had projects around containerizations, cost optimization, and disaster recovery as well. I'll speak more about the disaster recovery with Centage. With building a DR plan for Centage, we started with the absolute basics, right? Understanding the tech stack, the application, the business requirements, discussed mainly their challenges that they see, and then started translating them into technical solutions on AWS. We debated, we designed, and we built DR strategies based on their RTOs and RPOs. For particularly on Centage, we use natively the AWS Pilot Light DR strategy, which Shikhar explained a bit in detail. And the primary reason for that is they wanted to have it, wanted to create a second region on AWS and then always have a continuous data replication, but also to be in a low-cost staging environment, right? So all of the major infrastructure were in shutdown mode, but with a continuous data replication. So they get real low RTOs and RPOs in that sense. The results were mainly three. We were able to re-architect their infrastructure that helped reduce the overall IT cost by 50 to 60%. We also had a fully tested DR plan for their containerized applications on AWS and then databases that also met several of their compliances needs as well. And then once we completed the DR projects, we also supported them with 24/7 production go live support, right? So where they can focus more on their core business, improving their customer experiences, while we manage and take care of the AWS environment for them. That's in a quick summary of about Centage and how the engagement worked with them as well. I'm going to check for any additional questions before that. Okay, none so far. One quick thing is about wrapping up with a summary of this project, right? If you're looking for a disaster recovery strategy building and solutioning, Mission as a partner offers a complimentary hour-long essay on demand call. What it means is we get together with customers' broader team. We're bringing our solutions architect, customer brings on their IT team, and we do an hour-long scoping call where we understand your requirements, your challenges, areas that need helps with, and we offer them as a complimentary service. That also works along with a lot of funding programs with AWS. So since I mentioned Mission is an AWS Premier partner, we've leveraged the buckets of funding options that we got for several programs, such as building a DR on AWS. And then how to reach out to Mission is in two main sources. One is you can just hit the link and contact us, and the second one is speak to your AWS account manager, and that and he or she would able to help you facilitate a call with Mission as well. That's all on the project summary. Okay, I've got a couple of more questions coming in. Okay, the first one is the funding options available for such projects. Okay, We have several of them with Mission, depending on the segments the customer operates in. AWS has specific programs for startups, SMEs, enterprises, and all. Depending on the verticals, if you are into financial services, healthcare, and all of it, we leverage those specific funding options. We, to name a few, we work a lot with Jumpstart programs, MAP programs, where MAP is one of those key most valued funding program from AWS, which allows customers to move to AWS in a phased manner and also take the benefits of different MAP funding programs. It mainly comprises of 3 phases. That's a migration acceleration program with assess, mobilize, and migrate and modernize. Where in assess, we come in, we discuss, we understand, we do a thorough assessment of your existing on-prem environment, build out a TCO and do some cost analysis and help you with numbers and how your workloads translate to AWS. Then we do a mobilize phase, again, primarily for building the foundational pieces of an AWS and migrating or building the low-hanging fruits on AWS. And then we do the third phase, that's more on the migrate and the modernize phase, where you're trying to modernize your workloads once they are on cloud as well. Each of those phases have their own funding benefits and checklist, and we can certainly get on a call to discuss more. Okay, I also see a couple of more questions. The first one is engagement model available with Mission. Yes, that's a good one. We do have several engagement models how we can work with Mission. The first one is as a traditional professional services manner. When we come in, we scope out a project where we define the technical statement of work. We build out the estimate hours, the cost associated, and we complete the project along with you. We do also have a few managed services offerings, mainly around Cloud Elevate and Cloud One, where Cloud Elevate is basically an extension of your cloud team. We call it a pod-based approach, where you get cloud solutions architects, DevOps engineers working along with your team to complete a backlog of initiatives that you have. And the third one is called Mission Cloud One, where we work with as a completely operations and management for 24/7 cloud support. That has several pillars that we work with. Is around operations, maintenance and management, cost optimizations, things like security on AWS, support on AWS, and all of it. And again, that's a native Mission offered managed service. I have one more, and I would like Shekhar or Mark if they can answer it. The question is, we have 2 direct connects within our network account, but only 1 direct connect gateway. In order to leverage a second direct connect, we would need another direct connect gateway. Yes or no?
So that one I'm going to have to defer and do a little research on. I'm not that familiar with Direct Connect Gateway, but I think that question is from Chris. So we'll look into that and we'll definitely get back to you. Just not sure off the top of my head.
Okay, thank you so much. I think that's all for the day. After this, we'll pop up a quick poll for us to let us know if you would want to be reached out for a complimentary 1-hour SAOD call with Mission and our solutions architect. And we appreciate you taking this time off and attending this webinar with us. I hope you guys had a good hour spent with lots of understandings about the strategies and way to build it on AWS. We appreciate it. Thank you.